Okay, welcome back to my video. In this video, I will show you how to do many transient analysis on the same circuit, and also we can even combine frequency response analysis with the transient analysis. Doesn't matter. Now let's start. We have one option for say the transient analysis of 3 pulses, like in the previous video. Now if I go to simulation and edit simulation command, I will have to edit my current option, which is not what I want. So click cancel. Let's right click on the circuit, draft and space directive in the blank box. Help me to edit analysis command and stop time. As you could see somewhere here, you will see that the pulse period is around 8 milliseconds, and I want to have an option for only 2 periods of the pulse. So let's say 8 times 2 is 16 milliseconds. The rest you don't have to care for the transient analysis. Stop time is enough. Press OK. So now we have another option. If we press on run, you will have 2 options to choose from. I will choose the option of 2 periods. Click OK, and let's check the input voltage, only 2 periods, exactly what we want. So let's close it. One more thing to pay attention to: as you could see, the transient analysis for 3 pulses is deactivated. The sign to see that is the semicolon at the beginning, means the deactivation. If the transient analysis option has the dot at the beginning, then it is activated. Let's do this. Let's activate the 3 periods of the pulses. Move your mouse to the option, right click and change semicolon to dot. Click OK, and on the option, the 2 periods option, move your mouse to the option, right click, change the dot to semicolon. OK. Now press simulation, run. Measure the input. We could see 3 periods, so good. Now we want to see the frequency response. For the frequency response, we have to add some information to our voltage input, which is the small signal AC. You need to have an AC amplitude, whatever. Just put 1, or 2 or 3, it doesn't matter. 1, and click OK. Now we have one more option here, and we want to have the simulation for the frequency response. So right click on the circuit and to space directive in the blank white box. Right click again, choose analysis command, and we want to see AC analysis. Type of sweep, choose decade because we are in log. Number of points per decade, let's say 100. And here I put the formula of the break frequency or break frequency. Let's say break frequency of the first order low pass filter. So according to our circuit, with the resistor around 1 kilo ohm, capacitance around 1 microfarad, then the break frequency would be around 160 Hz. So to show it, of course 160 Hz should be in the range of the stop and the start frequency. Let's say I put the start frequency around 0 and stop frequency around 1 kilo ohm. No, sorry, 1 kilohertz. Press OK. They don't let me to specify the start frequency as 0. So I should put something very, very small but positive, like 0.001, and press OK. Now we have another option. You could see. Now simulation and run. Of course, I want to see the AC analysis, the frequency response. Click OK. Nothing happened because we haven't measured anything. Click on your output. Now this is the output. Let's check. Let's check. Put a cursor attach the first cursor to your layout, and here you could see I put the formula again here to check. This cursor is for the magnitude because the black dot is in the magnitude box. So at the break frequency, the magnitude will be minus 3 dB. Let's move to minus 3 dB. Okay, this is minus 3 dB. We have something around like 158 Hertz. Very close to the formula prediction. So everything is correct. And this is low pass because you could see the shape of the magnitude. It allows only the frequency lower than the break frequency. But everything higher than that frequency will be attenuated significantly. If you move the black dot to phase, then the cursor will be on the phase. So now at the break frequency 158 Hertz, we have the phase around like the phase shift around minus 45. So it's also correct because according to the formula of the first order low pass filter, that's how it is. The phase shift, why is it the phase shift? Because we have the phase of the voltage drop on the capacitor is lagging the phase of the input voltage about like 45 degree, as it specifies here. So that's what it means of the phase shift. So I think it might be clear enough. Let's do another demonstration. Let's deactivate this one and activate one of these transient. Move the mouse to that options, change the dot to the semicolon to deactivate, and change the semicolon to the dot in order to activate it. Let's run 3 periods. You could see it. Okay, good. If you want to delete some of the option, move your mouse to the option, right click, and you just have to delete it and press OK. Now it disappears. So I hope that this video is gonna be useful again, and see you in another video. Goodbye.